Hello, thank you for joining me today for this webinar. My name is James Hogan and I am the Applications Lead Scientist here at Scion Instruments. Today I will be discussing cannabis potency analysis. What do we mean by cannabis potency? What compounds do we test? Why should we test? And some of the analytical techniques that can be employed for identification and accurate quantification of these compounds. So the potency of cannabis is determined by its cannabinoid content. And here we have some example chemical structures of common cannabinoids. THC is the most well known and also the primary psychoactive ingredient that's found in cannabis, whereas CBD is the primary therapeutic component. There are over 500 chemical compounds in cannabis, with around 70 being termed as cannabinoids. In this webinar, we will discuss the 10 most commonly found cannabinoids. Now, cannabinoids exert their effects by interacting with specific cannabinoid receptors present on the surface of cells. These effects can be very wide-ranging, from control of movement, motor coordination, learning and memory, emotion and motivation, and pain modulation, amongst others. So why should we test for potency? Potency testing is important for the accurate labeling of cannabis products for medicinal, nutritional, and recreational uses. Potency analysis makes it possible to identify and measure the concentration of the cannabinoids present, which will then give us an indication of the strength of the product. From testing performed here at Scion, we found that label claims of cannabis products could be wildly inaccurate, as shown here in this table. Scion tested 4 CBD oil samples, all of which stated a label claim of 100 megs CBD content. However, when analysed, they showed results that vary wildly from the product label claim. Some of these CBD oils were also found to have other prohibited psychoactive ingredients present, while others had no other cannabinoids present. This shows how varied and complex these products can be. With governing bodies such as the FDA, the US Food and Drug Administration, looking to review their regulatory guidelines on cannabinoid products, it's becoming increasingly crucial to be able to accurately quantify the active components in cannabis products. Now I will discuss some of the analytical techniques that are available for testing cannabinoids. So here at Scion, cannabinoid testing has been successfully performed using gas chromatography, or GC, with either an FID, a flame ionization detector, or with an MS, a mass spectrometer for detection. For more information about the different types of detectors available for our instruments, you can see our website for guides such as Scion's GC detector guide. Now, there is a drawback to using GC as a technique for analysing cannabinoids. So due to the heated injector, which is required to volatilize the sample upon injection, which is crucial to the technique, the heat from this instrument part causes decarboxylation of the acidic cannabinoids, so THCA, CBDA, CBGA, and CBDV, as shown here in this table. These compounds lose their carboxyl group through the release of carbon dioxide and degrade into their non-acidic form. For example, THCA becomes THC, and so on. Therefore, these compounds can only be measured as their total content, as they cannot be distinguished between their acidic and non-acidic forms. Now, additional sample preparation can be performed by derivatizing these compounds so that they will no longer degrade and can be distinguished from their non-acidic counterparts. However, this can be a very time-consuming process. Now, there is an additional technique which can be used, high-performance liquid chromatography. There is no decarboxylation using this technique, and therefore the samples can be ran without the lengthy additional sample preparation steps, allowing for determination of both the acidic and non-acidic forms. Now, SCION recommends checking local regulatory guidelines before commencing testing, as total cannabinoid content may well be acceptable for your lab's needs, with no requirements to distinguish between the acidic and non-acidic compounds. This will vary from state to state and from country to country. Now, we found at SCION that all these aforementioned techniques gave satisfactory validation results and were able to identify and accurately quantify the cannabinoids present within the tested cannabis products. And I will give more information in later slides, and full detail can be found in our in-depth application notes, which are available on our website. So in these next 3 slides, I'm just going to give slightly more of an overview of the 3 techniques mentioned. So here we can see a GC-FID. This is SCION's 2 GCs. So we have the 8300, which is a smaller instrument, and then the 8500. So we were able to develop a method that was 7.5 minutes per sample, which is a pretty quick runtime, so ideal for a high throughput lab. And the technique of GC-FID, it's very robust, it's perfectly sensitive for the requirements of the method, and it's a very durable technique. We're also able to perform the testing using 3 different carrier gases. So historically, helium has been the carrier gas of choice for GC analysis. However, with the ongoing global shortage, this can cause problems. We found that comparable results were available using both hydrogen and nitrogen. The one drawback, as mentioned, for this technique was that without the additional sample prep, then for the acidic cannabinoids mentioned, it would have to be recorded as the total cannabinoid content. So again, here we have our 2 GCs, and they are both coupled with the SCION 8700 single quad mass spectrometer. Now, as with the last slide, this was using GC as the separation technique, so we had the same runtime of 7.5 minutes per sample. And again, the technique of GCMS is known for being very robust, sensitive, and very durable. Again, ideal for a high throughput lab. We do have less options for carrier gas when using MS. Helium is the preferred option. It can be used with hydrogen also, but there are some further difficulties with this. Again, for the acidic cannabinoids, without the additional sample preparation steps, it would need to be reported as the total cannabinoid content for these compounds. The advantages of using GCMS over GC-FID is that we are able to perform analyte confirmation using a built-in NIST database, which is perfect for qualitative analysis and also brilliant for any unknowns that may appear in your samples. And finally, we have SCION's LC. So this is the LC 6000. This particular method was a 40-minute runtime, so quite a bit longer than the GC. Obviously, we have no gas requirements, so there's no need to store high-pressure gases, helium and hydrogen. We do have the ability to discriminate between the acidic and non-acidic forms of the mentioned cannabinoids, as there's no decarboxylation. And again, the technique of LC is known for being robust, sensitive, and very durable. Again, ideal for a high throughput lab. Now, just to discuss sample preparation, just in brief. Now, sample preparation for cannabis analysis is absolutely crucial. So at SCION, we have tested both medicinal cannabis and cannabis oils. Now, the different sample matrices require different sample preparation techniques. So the sample prep for cannabis oil is very simple. It just needs to be diluted in methanol. However, for medicinal cannabis, the sample preparation is more complex. The sample needs to be dried for 2 hours before being ground to a powder. Now, this is a really crucial step, as we need to ensure that we provide a homogeneous sample for repeatable analysis. The sample is then blown down with nitrogen and then reconstituted in methanol. The full information on the sample prep can be found in each individual application note. So over the next 2 slides, I'm just going to give a brief overview of the results from the method validation and from the sample analysis from GC-MS and LC. So in this table here, it's just a summary of the validation results. So it was shown to be linear, with the lowest result being 0.39 and 1 there. So often analytical validation is considered acceptable if it's in 0.98 for an R squared value, or even 0.95. This will vary from regulation to regulation. And the results were shown to be precise and accurate, as can be seen from our QC sample. And the LOQs were deemed to be more than sufficient for the requirements. So, for example, the UK Home Office only issues licenses for the cultivation of cannabis plants from approved seed types with a THC content not exceeding 0.2%. Our LOQ was far below that. Here we have an example, so TIC, so total iron chromatogram, for the CBD peak in one of our samples. And then on the right-hand side is the NIST spectral library confirmation, so giving analyte confirmation there as well. We can just see a very brief overview of some of the results taken from our HPLC analysis. So we have linearity curves there for some example cannabinoids, and then on the right-hand side we have an example chromatogram that was taken from our Compass CDS software. Shows good resolution between all the measured components. The method was shown to be precise through repeated injections of QC sample at 15 microgram per mil. The RSD for these components was found to be less than 2%, which is considered to be acceptable for method validation. The method's accuracy was also determined by calculating the recovery of each cannabinoid in this QC sample, and it was found that each component was close to the true value and gave recoveries well within the 70 to 130% range that is considered to be acceptable for method validation. Now, full details of all validations for all the techniques mentioned and the sample results themselves can be found in our application notes. To briefly try and navigate the minefield of cannabis regulations. So I'll briefly discuss the regulations involved in cannabis testing, looking at the US market and EU and UK market. So EU and UK have been very slow to react, as has the US at a countrywide level, with the FDA still reviewing their regulations. However, the US at state level has been much faster acting, with many states already having their own laws and regulations. So in the US, nutritional cannabinoid products are not currently regulated by the FDA. Manufacturers are therefore not required to provide ingredients, nutritional information, or product warnings. I think with the expansion of the industry as it is, this will not last. As you can see here from this FDA statement, they conclude that the existing regulatory frameworks are not appropriate and they are working with Congress on a new way forward, so watch this space. So So, for example, in the UK, only certain cannabinoids are available for human consumption, those that are not classified as psychoactive by the UK Home Office, so for example, CBD. There's a quote here, which I find quite interesting, basically admitting that it's very difficult to isolate pure CBD, and therefore many of the products that are being sold probably do have psychoactive components. There is nothing in place currently to regulate this. So this policy provides that licenses may be issued for the cultivation of cannabis plants with a low THC content, for the production of hemp fiber for industrial purposes, or the obtaining of seeds, which are then pressed for their oil, for CBD oils. Currently, they only issue licenses for cultivation of plants from approved seed types with a THC content not exceeding 0.2%, as I mentioned earlier. I think overall it shows there's a lot of work to do in a regulatory sense. I think this presents a fantastic opportunity for labs worldwide to be the leading light in cannabis testing and to help drive these regulatory bodies into deciding the testing involved and the limits required from country to country. So to conclude this webinar, cannabis potency analysis can be determined using several analytical techniques, and we've discussed 3 here today that have been used at Scion. And of these 3 techniques, the use of HPLC negates the need for complicated and time-consuming additional extraction procedures, and so may well be the preferred analytical technique. Hopefully I've made clear that potency testing is very important for the accurate labeling of cannabis products for medicinal, nutritional and recreational uses. We've seen from our results that you can have a huge variation from what's on the label claim to what is actually present within the product. So just to quickly mention, if you visit our website, cioninstruments.com, not only will you find the cannabis potency application notes mentioned today, but we also have other cannabis application notes available. So determination of terpenes, which we've done by GCMS and GC-FID, residual solvents by GCMS, and also THC in bloods content by GCMS. We also have available on our website TechComp, which is our parent company, has put together a brochure for cannabis and hemp laboratory products, which is designed to take you from start to finish, from sample preparation, sample storage, sample analysis, and that's a collaboration with our sister companies. Thank you very much for attending this webinar, and we will now have a Q&A session.